Hello everyone, this is going to be a video mainly about Qdrant and also LangChain and vector databases. So if you're interested in that along with Python, then keep watching. What we're going to be looking at first is embedding and upserting text into Qdrant. Now if you've not come across Qdrant before, Qdrant is a vector database. So Docker pull Qdrant, Docker run port 6333. You can get it up and running on your own machine. And then as soon as it's running, you can either use REST or you could use gRPC, that's on a different port. You get a Python client for it, so then you can actually use the Qdrant client to query the vector database and also to do your upserts and create your collection. So a collection is basically a bit like a table in a traditional relational database. With vector database, you have many vectors. So it's a bit like columns in a relational database, except obviously they're all over the place. So yeah, I'm not going to go into the details of that, but as you can see, that's kind of like a really basic example. You've got bash example, you could just run that on you didn't want to use Python. So what I'm going to cover is actually two different methods of querying. So if we imagine we've got text, so that could be a book. So let's call it yeah, all that's going through Python script, which is going to do the embedding or encoding, and then it will do the upsert. So upsert is kind of bit of a different word to what you're probably used to if you're coming from a relational database background, but upsert is basically upload and insert, isn't it? I think it's portmanteau. So then that ends up in Qdrant. I know I'm talking quite quickly over this. We'll go into more detail as we progress through the video. So the text ends up in the database, and it's all just kind of it's scattered around over your X and your Y and your Z. So you, some bits are up here, some bits are down there, some bits are back there. And then when you ask it your question, if your question happens to get encoded and it's over here, then obviously it's gonna pick out that particular vector there is going to be your answer. So there's two ways of querying this. One is actually free, and that's with the Qdrant client, and it does the Facebook AI similarity search. So that Qdrant client is also Python, or you can get Python wrapper for it. So your query would be something like, the response back would actually be a paragraph of text. So you'd actually end up with, but doing it this way, you'd end up with loads of lines. You'd end up with basically a chunk of text, which somewhere in the middle, it would say the rabbit chain. Then you can query it more accurately, and you can give it, you can specify how you want the result to be as well with like a prompt. So you could say, please reply with the color of the rabbit and put it as a key value pair. So you could actually get it back as JSON. So yeah, you've got the free method, which is one input script, and then we've got two kind of query. We're going to have two different ways to query. So the first thing I'm going to show is, if you want to skip ahead, here we go. So the first thing we do, it's obviously chronological. So the first article I wrote on July the 20th, 2023 was text embedding and upsert, and then obviously the follow-up one was question answering. I've put in the details of all the pip install requirements, how to set up the Qdrant database, the Docker image, and then you run the Qdrant Docker container. This is the code. We'll look at this in detail in a minute. So basically, the Python script uses following libraries: LangChain vector stores, LangChain embeddings, LangChain text splitter. So to actually prepare the data to upsert it, you don't have to use LangChain, but LangChain obviously have now provided the text splitter, which is really convenient. So you import the libraries, create the collection. So the collection is basically like the table name. The text splitting and chunking. So you import the 10,000 word text file, novel, book, whatever. If it was PDF, you could import PDF, or you could convert the PDF to text. I think LangChain supports PDF as well. It's got a PDF loader, and then you embed the text using sentence transformers. You can pick your model really, as long as it's small. Obviously, you don't want something that's going to be hundreds of gigabytes. So that, even on my old laptop, that installs quite quickly. MS Marco Mini. So if it's got the word, if you see Mini in the title, you're probably onto a good thing. And then at the end, we insert the embeddings. So let's actually have a look at the code. You can go to my website, Red and Green, and you can skip ahead if you want. But here's the code again. That's the sentence transformer there. Let's just zoom in on this, and I'll put it in. Let's go to Zen mode, shall we? Zen mode and zoom in. There we go. You can't ask for more than that, can you? So you've got the inputs at the top, LangChain vector stores and embeddings, text splitter, which I've just discussed. You've got the Qdrant client, which gives you Qdrant client models, collection status. I use the collection status because one of the things I'm going to show you, which you don't come across in many tutorials, is if you want to append to your vector database. So say you've got a vector database and it's basically got vectors for several books, and then you want to add an additional one. Quite often in the tutorials you'll see recreate collection. Don't run that, because recreate collection will actually delete your collection and then create a new one from start. If you're think of SQL, you don't want to drop the table and then create a new table. Okay, so then NumPy, we use NumPy to create the two-dimensional, to create the list of vectors that we then upsert. Sentence transformers, so that's actually doing the transformation of the sentences. Collection name, so yeah, originally I was going to do this as some kind of like PDF based thing, but I thought better of it really. It was just not entirely relevant. So my collection name, you can call whatever you want. That's just what you will refer to your, again, think of it as the if in SQL sort of think of it as the table name. Text, we'll progress to make that a list, a proper list, but at the moment it's just a list with one book in it. Alice in Wonderland, which I got from the gutenbergpress.org, I think it is, where all the free ebooks are all on there. You can just go to the text version. Let me show you. Gutenberg ebooks. There you go. Um, 70,000 free ebooks. They're not all sort of novels either, so if you want something sort of a bit left field, it's on there as well. Bookshelves frequently downloaded. Yeah, anyway, that's I've gone off on a tangent. The client is, let me just zoom out a fraction so we can fit all that on the screen. I didn't have the time or the patience to get gRPC working, but 6333 is the standard port to access the Docker container. So you just create a client object, which is basically running on local host. If you were to deploy this to a web server, you would still run it as local host, and then you would obviously do some kind of reverse proxy thing to it with Nginx. I have done that. If you go to findthatbit.com, that's actually running live, and I've done that. I've set up a Qdrant Docker container running behind Nginx with reverse proxy, so that the requests hit Nginx for the HTML page, and then it goes off and hits the. What did I do? I can't remember. I wrote an API. I might have done it in Rust anyway. So I've written a function, and then I've used the function. All the way through this, you'll see I write the function, use the function. I've not used classes, and I've not used main or anything. So I've tried to keep this understandable if you've come from like a Jupyter notebook kind of background. So and also you can this doesn't then need to be the whole thing. You could just come in and copy and paste a function if you wanted to just use part of this to use in your own project. So make collection. So I'm passing in the client, which we've just talked about there, the collection name, which we've talked about. So what we do here, this is the recreate collection. That will build the collection from scratch. So if I comment that out and do make collection, then that obviously calls the function, which will then make a brand new collection. So this function, you can leave that as it is, but obviously you need to comment out make collection, because you don't want make collection. You don't want to call the function and recreate the collection, because you'll lose whatever you've got in your current collection. Make chunks, import. Sorry, you pass in the input text. The input text is yeah, we've got alice.read. So that is the actual file that you're passing in. So the file you pass in is your input text, which actually in our case is text, which is Alice in Wonderland in this case. So when we call it, we're making the chunks with the Alice in Wonderland book that we've downloaded from Gutenberg Press. So we've now got an object of texts, which we've split up into lots of chunks. Chunk size 1,000, that's 1,000 characters. We've done chunk overlap of 20. Imagine if you chopped a sentence at the 1,000th character, it might be halfway through a sentence, so it wouldn't make sense. You've destroyed that sentence. If you've got another sentence which kind of overlaps, then at least one of those two chunks will have, hopefully, you'll have the full sentence in it. So you've not lost a sentence to gobbledygook. So create the vectors. So what we've done so far is we've chunked the text. We've created a vector database. So now what we want to do is we want to process the text into batches, and then we want to convert those, then we want to encode it. So encode those chunks, and then convert those. You see here we go to for item and text, then we pass that into vectors. So vectors, and then we're returning vectors and payload. So the payload is basically the human readable version. The vectors is the kind of 0.932, 0.719. So I think here we're getting 384 vectors per item. You could have 768. You can have way more than that. I've kept it small. So then I'm reading I'm setting these two variables from the tuple that gets returned from this function. So genVectors is basically taking in the text, the model. So the model is basically the mini LM large language model. And we've got batch size, and vectors, which I've set all those up the top. I think I skimmed past those, but there they are: vectors, batch size, 512, and batch. So then once we've actually got the vectors, the final vectors and the final payload, we can iterate through those, and they need to be iterable because with upsert, we're passing in the collection name, and then you're passing in something called points. Is that going to show me the? No, it's not. So you're passing in a point struct, and the point struct is basically here. So it's part of a list comprehension. You see the square brackets. So for every ID and vector, we're enumerating the final vectors. And the final vectors comes from up here. So I think for Alice in Wonderland, they had something like 160 odd or something like that. Because if you remember, there's 160, effectively 160 chunks. So we've got ID. The ID, I don't know if this is the best way to do it, but this is how I do it, and this works. And I've not seen this anywhere else. Partly because nearly all tutorials just assume you're just creating the collection and you're never going to append to it. Whereas I think in reality, you're always going to want to append to your vector database and add more content as time passes. And you're not going to just want to start a new vector database each time. Again, if you go to findthatbit.com, I keep adding to that as more. So basically, that's a similarity search on YouTube videos, and it allows you to search hundreds of YouTube videos. Or search basically the captions or the subtitles across hundreds of YouTube videos, and it looks for similarity. So it's not looking to see if somebody said a word once. So for instance, there's like a Bitcoin video on there where somebody was talking about Miami beachfront property. But if you'd just gone on there and you'd just searched seaside or coastline, it still would have found that part of that specific video. So yeah, that's where the power is. So what I'm doing here is basically because the index, you don't want to overwrite the index with when you import your second book, you don't want the index to start at 1 or 0 again, because you can overwrite what you've already got in there. So what I'm doing is collection info. In fact, I should call that collection index count or something, but I'm basically getting the information about the collection, and then here where the ID is, I'm actually getting the vectors count, and then add in the ID. So to start with, it will be, if I've already got 150 things in there the first time, it will be 151 and then 152 and so on. Vector is vector. Vector comes from here, which is the so you've got, because we're enumerating this, we've got kind of the index, and then we've got the actual thing we want. So vector, so each time that will just progress by 1. Payload is the final payload that we got from our function up here, where we did gen vectors. And the IDX, again, that's just the value of the current iteration of that list comprehension. And then once we've done the upsert, once we've written the function, so that's all the function down all here, and then we just run the function at the end, and we're just passing in the final prepared vectors and the final prepared payload. So obviously, as I said before, the vectors are what we've prepared from the encodings. The payload is basically the chunks of text, because you want your vectors and your chunks of text, because you're going to be searching based on an encoded question. But when the encoded question matches your encoded data, then you want to actually return the human readable payload that matches it. So there we go. Right, that is the upsert, and really the key things to take away from this are that I am appending to the vector database, and also that I'm using LangChain text splitter. You don't have to. I've done this project before without using LangChain for the upsert script. So TQDM, that just gives you a nice progress bar when it's running. So NumPy, remember that you need to be making a list of NumPy arrays. So that when you do this, you'll almost certainly get errors where you haven't got the right type, you haven't got the right data type. So, or to just do print type and then variable name, because you need to keep checking whether you're working with a dictionary, with a list, with a NumPy array. You see here np.concatenate vectors. So I keep adding. So vectors is actually yeah, it's getting added to, and that's what we then pass in as the final vectors. This is probably not the most interesting video as yet, but let me just show you. Let's move on. So let's just show it running. What I've got is, you can see on the left, I've got the Docker one. So I've got one terminal window on the left where I fired up Qdrant in the Docker container or Docker image. Right here on the right hand side, let's run Python Qd client. So Qd client is this file, which is the one that uses the large language model. In a minute, I'll show you the one that doesn't, because you can query your vector database without needing to use a large language model. So you can just use it in Python, and that's cheap, fast, and really good. The only problem is it returns a big bunch of text, like I showed you in. So if we go back, we'll just quickly hop back to the diagram, if I can find it. No, I can't. Sorry about that. That's the basic documentation for Qdrant, but as I say, it doesn't really go into appending to your collection. Right, let's okay, right, so we've got the LangChain version here. This is the LangChain script. So this is script 2, which is the second article on my website. So if you go up here and you can find LangChain question answering with Qdrant and GPT 3.5 Turbo as of 20th of July 2023. So again, covers much of the stuff that I've already talked about with setting up Docker and the Qdrant client. So this here is the script that I'm about to show you in VS Code. It's obviously bigger font, so I'll stay here. I'm using Chat OpenAI as opposed to just OpenAI. This is so much cheaper. I think it's about 30 times cheaper. So rather than OpenAI, which you'll see many places, you don't have to use that. And for a lot of purposes, Chat OpenAI. So OpenAI is kind of more powerful, but you only need it if you're doing kind of well, obviously, if you're doing stuff which you can't do with chat. So here we go. We're just going to do this with chat. From LangChain chat models, import chat OpenAI. So this will cost about 0.001 of a dollar. So it's about 30 times cheaper than using OpenAI. It's still made by OpenAI. It's just a different. You got chat OpenAI and then you've got OpenAI. Temperature to 0 because we don't want it to be creative. I always think that's funny when people that you say if it's being creative makes you think of politicians, because they're creative with the truth. Embeddings. So here, HuggingFace embeddings. It's just basically getting the model. I'm just telling it. I don't even know if I needed to use that, but it's from LangChain embeddings, HuggingFace embeddings. So I'm just instantiating the HuggingFace embeddings class with the sentence transformers Marco mini LM model, because this is necessary because we need to encode our question, because we're trying to compare our encoded question with our encoded data. Sorry if I keep going on about that, but so much of this is still kind of new. Client equals Qdrant underscore client. So basically that's the Qdrant Python wrapper, and then we're going to use the Qdrant client method, which you create a Qdrant object, which is using the Qdrant client, which we've just created here. So basically it needs to know where you're hosting it. It needs to know the name of your database. Oh, sorry, the name of your table. Collection name. I'm going to stop comparing things to old school, so it's just your collection name. So it needs to know where it is, what it's called, how it's encoded, and where the kind of the human readable stuff is. So there we go. Where is it? What's it called? How's it encoded? Where's the human stuff? And yeah, then we create a thing. This is a LangChain. So the LangChain bit starts here. So far, everything you've seen really is, apart from the text splitter and the upsert script, which was optional. You wouldn't have to use that. Retriever equals Qdrant dot as retriever. So it's the vector store retriever. So we're basically saying, hello, Qdrant object, can you go and retrieve some stuff? And then the RetrievalQA needs to know which language model to use, the chain type, and then the retriever, which we've just set in the line above. This question actually is not a good question because it didn't actually feature. So I just ended up with an answer saying I've no way of knowing the answer to that. So, but I've upserted Alice in Wonderland and a 170-year-old book by Frederick Bastiat, who was writing about the French Revolution. So I've got quite a mix of stuff. So what I'm going to ask it is, remember this is using a large language model, so I've had to use OpenAI chat model. I have got my API key set hidden, is set in my .env file, and I'm gonna do QA run. So that's the QA is set here on 28. You can see what's going on. Right, so run it. Now I've asked it to answer, give me the answer as basically a Python dictionary. And if you're watching the left-hand side down here as well, you might see the, there we go, something happened there. It was just it posted the request to collections PDF Z points. There's your answer. So that has gone off and set the answer to white. So what color is the rabbit? So the white rabbit is white. So color key, the key of color value equals white, and the key of wearing a splendid dress with kid gloves and a large fan. I've not read Alice in Wonderland recently, so I don't know if that's I can't verify that's accurate or not. So let's just so remember I've loaded this up with 2 books. So we'll go for let's go for question 2, and we'll say so the Frederick Bastiat talked about plunder. So you would expect that to find the more accurate answer in the Frederick Bastiat book rather than in Alice in Wonderland book. And I've not told it to return the answer as a key value pair, so we should just get I haven't told it a character limit, so we might get a more verbose response, which we have. Do you want me to read that out? Anybody into a bit of controversy? Governments may engage in plunder for various reasons. One possible reason is that they seek to benefit themselves or a specific group of individuals at the expense of others. This can be done through policies such as excessive taxation, corruption, or favoritism towards certain industries or individuals. Another reason could be to maintain or consolidate power by controlling resources and wealth. Additionally, governments may engage in plunder to fund their activities or fulfill their obligations, such as providing public services or financing wars. This was written 170 years ago. That's amazing, isn't it? It's never been more prescient. It is important to note that all governments engage in plunder, and there are many governments that prioritize the well-being. Oh, sorry, I missed the not. I thought it said that all Okay, let's reread that. It is important to note that not all governments engage in plunder. I think they do. And there are many governments that prioritise the well-being and rights of their citizens. Actually, I can only think of one country that doesn't engage in plunder, and that's probably El Salvador. But I don't want to get banned or anything, so I'll quit while I'm ahead. So what we've just seen is the version where we use the large language model to query the Qdrant vector database, which has got the data in it that we've encoded and upserted using our first Python script. So let's look at the other script I've done, which is this is actually a bit more textbook because I've made it into a class. From Qdrant client, import Qdrant client. From sentence transformers, import. So sentence transformers is basically to encode we're encoding the question. The neural searcher, we're passing in the collection name. It needs to know the collection name, it needs to know the encoder, and it needs to know where it is, which is the usuals. Search, so the search is basically pass in what is your question. So the search, where I use it, you can see down on line 34, the search is actually what color is the cat. So that's the text that goes into the search, and then that gets encoded. That gets to list. It's been a while since I wrote this. In vector equals model encode to list. Oh, of course, yeah, because you want a list of the vectors. So you have a list of the vectors because you've got, what did I set the vectors to? 3, 8. I think I set them 3, 8, 4. Just bear with. I think if you don't set the vectors, it actually, oh, there we go, 3, 8, 4. You see that on here on line 47. So that's why we're using a list, because it's the 384 vectors is basically, it's a list of 384 items. Right, sorry, back to this. Let's go back into Zen mode as well, because it's a bit neater, isn't it? So yeah, we've done the imports. Just remember, if you're doing this on Linux, you may need to use sudo when you run the Qdrant, when you start up a Qdrant Docker image and container. Yeah, so when we instantiate the class, it's basically, it needs to know that it knows the collection name, it knows where it is, where the Qdrant vector database is running from. It knows which model you're using to do the encoding. We create a list of vectors. The search result is basically the use vector for search for closest vectors in the collection. So this here is what's actually doing this is the Qdrant part, which we're basically just writing Python code to actually make this Qdrant client search come back with something useful. You can also add a filter. So the filter filters on the human readable stuff. So obviously the search to begin with is a filter because you're filtering on stuff that's most relevant. But you could also search, if you returned 10 answers, you could also filter on, you know, if you're searching for what color is the cat and you get, you know, red, white, and blue, you could just filter on. Sorry, that's a bad example, but if you're filtering on something, you could just filter out stuff that you know is blatantly not accurate or not necessary to your, not pertinent to your answer. So the payload is basically creates it's a list comprehension which you can then iterate over. So down here, I'm doing for item in response, print the page content. So if we come back out of this and I just run it, so remember this is basically the free version, should we call it? So this is the neural, what do I call it? Neural searcher. So this is going to go off and perform the search for what color is the cat. And I would think that's probably going to find me an answer from Alice in Wonderland as opposed to a book from 1850 by a Frenchman about government. Here we go. So this is basically this is returned the chunk. So the chunk was, I think it was 1,000 characters. So you're actually going to get. I tell a lie. Did I set that as 2? Yeah. So I've returned the first 2 chunks. So we'll read it anyway. The cat and he grin saw Alice. Blah blah blah. In fact, I don't think the color of the cat is actually mentioned, but it does. Obviously, the cat features quite heavily in this result that is returned to us. So, from a semantic similarity search point of view, this is the most similar, based on the encoding of the question against the encoding of the original chunk. If we ask that same question, so basically it's returned us this long paragraph, and I know this already because I've tried it. Nowhere in this paragraph does it actually mention the color of the cat. Pretty sure it doesn't. So, but if we come back here, we can just verify that. What color is the Cheshire cat? And then we run the QD client. So it's querying the same data, but it's obviously querying it a different way because it's doing the retrieval, and then the large language model is able to make better sense of the text. It's got, I was going to say more intelligence, but that's a zoomorphism. If you've not heard of the word zoomorphism is basically where you give human human-like attributes to non-human things. So the text does not explicitly state the color of the Cheshire cat, which is why we got all this text back when we did the Qdrant client search. We got all this text, and it was very relevant because it was all about the cat, but it didn't mention the color because, as we just found out, the color was never mentioned of the cat. The rabbit was white, which we know. So, that is kind of my overview. Again, a lot of this is unless you're doing it every hour of every day, you kind of just think, oh no, is it a list? Is that an iterator? But a few tips. Always remember that NumPy, use NumPy array, and if you're not sure where you're going with it, just do print type. Just just remember whether you've got a list or you've got an array. Splitting the chunks, again, the chunks is don't confuse batch with chunks. So batch size is basically a way, well, it is what it says. It's a way to batch your uploads. If you would upload in some, say, a book that was that thick, then it would do it in 512 batches of 512 chunks. If you're used to using sockets, you'll know that you send stuff in kind of in chunks. You don't just send a whole bunch of stuff in one hit. It's got to be sent in little smaller bits, parcels. I was going to say packets and bits and frames, but yeah. This isn't a networking tutorial. This is how to upsert text to a vector database and how to query it using a large language model in LangChain, and also how to use Qdrant's own built-in client with Python. So 2 ways of doing it. One gives you a very verbose response. If you go to findthatbit.com, so this is my main website, redandgreen.co.uk. So the articles are here with the gists. So it's all here. You can pick it apart. Just if you only need to understand how I did part of something, then just pick out the bit you need. So what I've got in here is I don't know, 100, 200. I've encoded the subtitles or the captions from, say, 200 videos on YouTube. So what I'm going to type in here is coastal property. I'm typing this in because I know it's in there, because it would make a rubbish video if I just got nothing back. So I'm typing in coastal property, and the first result we get back is beachfront property in Florida. So, but they're talking about how you can store value in land and property, but you can't transport it. Whereas with Bitcoin, you could emigrate and you could still access it. So it's portable. You're able to store your wealth in something that's portable as opposed to something which is fixed. And he also talks about the property tax in Florida, where he pays 2% property tax, which is on £1 million property is a lot. So that's done a similarity search. So let's try something else. Let's try Rome. I know that he talks about the Romans engineer. So I think because I put in Italian, that might come back with Roman engineering, and it might come back with something about aqueducts or something. Oh no, it's found, but see, because engineer appears 1, 2, 3, 4 times in that sentence, it's picking up engineer. In fact, let's put in something that's a bit more a longer sentence. So tell me about ancient armies. So there it's talking about, and then immediately it's done a similarity search on the encoded. So it's encoded my question, and it's matched that against a vector, which was also encoded from the original text. And then it's talking about Spartans, Athenians, Persians, Romans, conquer. So, but as you see, that's returned a big chunk of text. So that is, when I say chunk, I do mean that. That's how it would have been coded. But in addition to that, you can also bring back metadata. So the metadata I also stored in that vector database was another key value pair for the video ID, and another key value pair for the URL of the thumbnail. So it was like thumbnail underscore URL, and then each one that I uploaded had obviously a different thumbnail. They are all different. Those two are the same because this is found 2 results which are very relevant to my question. And I just arbitrarily chose to return 5 results because that's what fitted on the web page quite nicely. So if you come here, features, yeah, I made a note of which model I was using there. So that was the Mini LM L6 V2 sentence transformer. So much like what I've just showed you. If you want to send me some sats, that's my QR code. If you want to contact me, then that's the link to my red and green site. Yeah, so if you want some some really good fast Linux hosting with Python already installed on it, Python 3.10, you can install Nginx, is it like well, actually it comes with Nginx installed if you choose the right model. Really fast hosting, Linux VPS, just excellent. That's what this is hosted on. So you can actually check the performance of these page load times and everything. So I'm hoping they're not overloaded right now, because that would not make a very good video. But let's try it. There we go. 66 milliseconds, and that's hosted in Denmark, I think. The LangChain and Qdrant examples, they show you the text splitter, and it's basically put in state of union, chunk size, chunk overlap. You see there, they've got chunk overlap as 0. Really, you want to be doing that to more, because otherwise you could potentially end up with some sort of, if the first paragraph or sentence was 1,050 characters, you're gonna, you could lose a bit of meaning with that. Whereas if you had like a 20 character overlap, you got more chance of getting it. Local mode. So there's your usuals. So yeah, so docs, embeddings, location, memory. So that's where you're running it in memory, but obviously the whole point is using it as a database, so you don't want to be doing it all from memory. You want to be inserting or upserting. Yeah, so that's what we were looking at as retriever. So I mean, all the documentation's fantastic, but it's not always quite in depth if you're doing something a bit bespoke, should we say. Yeah, so in Pinecone, so in Qdrant it's called payload vectors metadata. It's just got slightly different syntax. In fact, I've come straight to the LangChain part of Pinecone, which I shouldn't really have done, but let's go back up. Pinecone, let's go to products. All I wanted to do was tell you what the difference in the syntax was. I think they call it meta embeddings and install Pinecone, get your API key. So yeah, to do all this, you need I think you get one free collection with Pinecone. And the other thing is, if it's not used in 7 days, I think it kind of gets archived or something. So if you're on a tight budget and you're willing to run a Docker container, then so the cloud versions, obviously Pinecone's sort of predominantly cloud, and Qdrant is kind of, you're really renting some space on that on Amazon or Google, really. Obviously the vector databases the code behind them. The reason why it's so good is because it's obviously been highly optimized to make it run quickly. If you wanted to write a vector database, I'm sure you probably could in Python, but it just wouldn't be very quick. So this is semantics. This is the Pinecone version in a Jupyter or Colab notebook. So they've basically encoded using the all mini LM L6v2, which is what I used for my findthatbit.com. sentence transformers. So whether you want to use Pinecone or Qdrant or whichever, it's the underlying features and the underlying libraries and stuff are pretty similar. So yeah, metadata, which you might see is called it's got ID, metadata, values. Yeah, just there's some slightly different syntax with Pinecone, but there we go. If you want my code, each of those 3 bits I showed, 3 scripts I showed you, are all public on my GitHub. I've put articles about the upstart, and I put an article about question answering with the large language model on here. The third one, which was the Qdrant kind of built-in Qdrant.search. I haven't done an article about that because it's very similar to this one, and also you could really base that pretty much on the Qdrant's own documentation. So yeah, there you see what colours the Cheshire Cat, etc., etc. So don't always expect an answer, because if the information if you've not upserted relevant information, it's not going to be in there. So LangChain, Qdrant, HuggingFace, and yeah, the text embedding really is the one that you won't see elsewhere on the internet, because I'm appending to the collection, which most tutorials won't show you. And yeah, the way I'm doing it, I'm probably not, I don't know if I'm doing it the best way. I'm doing it a different way, really. I've kind of taken a couple of different tutorials and just kind of picked the best bits from each of them. So there you go, vectors, upsert, and then you query it. So thank you for watching. Any questions, put them in the comments. Subscribe, thumbs up, all the usual. If you've got any recommendations, if you think I'm doing something not quite right, then let me know. The way I've done this, just with a function, then call the function, then write the next function, and then I take the answer from the previous function. I've done that deliberately to keep it simple in my head, and also to make it simple for a new person to try and understand it. So, yeah. Qdrant, LangChain, OpenAI. Remember to use OpenAI chat model because it's 30 times cheaper. And remember, the recreate collection, only run that once, because the second time it will overwrite your first collection. So that function there does recreate. Recreate basically removes your original one. So that's why it's commented out there. But the first time you run it, you will need to obviously make your collection, because the first time you run it, you won't have a collection, because when you start up Qdrant, there are no collections. So yeah, it's like an empty database with no tables. Think of it like that. Also, depending on the model you use, if you use a different model, different embedding for your sentence transformer, just check that out on Hugging Face, and it will tell you how many vectors you need to use. And yeah, first result, Hugging Face. And if you go, see, it tells you to use pip install sentence. So these instructions are just for how to kind of use it in Python. It's not deliberately mentioning. It's not. These instructions are just kind of mentioned for using it. Qdrant is Qdrant.tech. Hugging Face for the models. And Gutenberg Press, Gutenberg.org, to get loads of books in text format if you want if you want to get those and upsert them into your collection. And don't forget to hash out make collection, because you only want to make the collection once. The way to test it, you can go to Thunder Client, which if you've got VS Code is an extension. If you create, I've lost it now because I've made my fonts too big. Right. There we go, Thunder Client, new request. So it defaults to a GET request. And we're going to do it's in my history there, look, HTTP 127.0.0.1, port 633, then /collections. That's going to get information about all of my collections, where I've only got one collection, so you see. And then if I did / and actually put the collection name, rather than getting information about how many collections I got, I should get actually information about the actual collection. And you can see 279 vectors. So that's, I think the first book that I uploaded, Alice in Wonderland, was something like 130 lots of 10,000 characters. Sorry, about 130 lots of 130 chunks of 1,000 characters. Then the second one was yeah, just a bit more, a bit less. Can't remember. If you don't know what some of these things are, just be curious. HNSW, Hierarchical Navigable Small World. Time. Look at that time. This is written in Rust, by the way, so this is lightning fast. Look, 0.00. This is very, very fast. It's written in Rust, if anyone's interested, with, I think it's the Actix framework. Yeah, there you go, Actix. And they're using a middleware to do the login, which is what you're seeing on the screen. Qdrant, Access Web UI. Oh, it's got the, yeah, let's go to the dashboard for that then. I forgot about this. So yeah, you can view it here. And yeah, rather than doing it, obviously this is just for kind of development or for learning, really. Once you've deployed something, you're not really going to be doing it much in the GUI, really. You're just going to be set it up, script it all in Python, and just hide it behind an API running on Apache or Nginx, and off you go. But yeah, these are the points. So metadata, index, start index, vectors. So it doesn't actually show you the vectors, but obviously why would you want to see a bunch of 0.01, 0.1, 0.7, 0.6? Oh, so that's the index. That's the index of the vector. Yeah. Okay. Oh, and it's got a console as well. Wow. Let's make it go into dark mode. Make the font a bit bigger. What's this do? Reset history. Run. Okay. Get collections. Get collection. Just going to take this out. Okay, so then if you do get collection name, so if I, so the bit I'm typing in now is kind of the console. So get collections, EDFZ, and then I don't need to run all that, I can just do that. Okay. So that's basically a bit like what I was doing in Thunder Client, wasn't it? Just then, but Is it actually giving me anything else? Don't think it is. Do you remember when I just said about HNSW, hierarchical navigable small world? So that you can actually, I guess if you were on a mobile phone or a tablet or something and you didn't have VS Code installed or whatever, you could just come in here and use the console. But yeah, collections. Oh, and you can delete the collections from here as well. And the API key. Oh yeah, so for the Docker image, you don't need an API key, so it's because it's free. If this was this will be the same for the cloud version. So if you're doing the Qdrant cloud version, then you'll need your API key because you have to pay because it's run on Amazon. Was it? I think it's on Amazon. So yeah, a little bonus for you. There's a little look at Qdrant. Yeah, that's probably enough for today. Thanks for watching. Hopefully you learned something and it's been worth your time. To be honest, sometimes these videos are best watched at 1.5 speed or something, but if nothing else, go and look at my website and just get your head around how you can do upsert with Python. You can upsert some text using Python and Qdrant to a vector database, and then you can query it. And the whole beauty of that is you can get back an answer based on the semantic meaning of what of your book or your books. And you can use LangChain, which is amazing because then you can use, once you can use LangChain to query your data, then you can get back a very accurate answer, such as a Python dictionary with key value pairs of the color of the rabbit in Alice in Wonderland and what it was wearing. So what's not to like? Thanks for watching, and I'll see you again soon. Cheers.